Hello. In this demonstration, I will show how to summarize a PySpark regression model. The summary will be like that provided by packages in R. So here's an example of a regression where we're using a pipeline. First, we have a R formula, which is basically all the columns except for price. And we're going to put that R formula into a pipeline, followed by a linear regression. So the R formula specifies the formula that's going to be used by the linear regression. Once we have the pipeline, then we're going to fit it to our data. And we get a fitted model. And the idea is we want to summarize that model. And a common way of summarizing a linear regression model is found in the statistical packages for R. For example, this common summary of a linear model shows the call to the model, which is the formula, followed by the residuals, the coefficients, including the intercept, and for each one, an estimate of the coefficient, standard error, t-value, p-value, and other things such as the residual standard error, R squared, adjusted R squared, and F statistic. And the issue is this is not easy to be obtained through the standard PySpark regression models. So I've got a notebook that prints out a similar R-like summary. It shows at the top the residuals, the equation, coefficients, and the appropriate values for those coefficients, including even at the bottom the F statistic. So in addition, when you want to summarize a linear model, typically you'll plot the actual values versus the predicted values, and hopefully they align pretty well, and that means your model is pretty good. So I'm going to show how to do these kinds of summaries for a linear model in PySpark. So let's go to the demo in the Databricks using a notebook. Here's my Databricks notebook. It has the data that I'm going to download. Once the data is downloaded, I can use Spark to read the CSV file. I can review the data, and in this case, the data has some odd column names, so I rename some of the columns, I convert the type of some of the values, and eventually I get this data set for USA housing data, and it's in a Spark data frame. Once I have that Spark data frame, then I'm going to go ahead and define an R formula here, which I'm going to use for my regression, and I'm going to create an instance of a linear regression, put it all in a pipeline, and fit that pipeline to my training data. And as a result of all of this, I'll have my fitted model, which really is a fitted pipeline. And that way, if you take the second element in the list of stages, you get your linear model. And the idea now is to summarize that model. And if you look at LM, that's the model, and lm.summary, that's the summary that is provided. And within that summary, you can print out things such as R2 or R squared to see the summary. Unfortunately, it's a sort of a pain to go through and select all of the elements you want to print out. So I've done that here. So here's a function that prints out the summary. And you could see somewhere buried in here, I take the summary and print out R squared and also adjusted R squared. And some of the other things that we'd like to have and are found typically in the R packages. And I also rely on some helper functions here that determine the residuals and also F statistics. And this is going to return my residuals. And so when I call my summary, I have this sort of side effect where I get the residuals, and I can do something with the residuals, which is typically plot them. So, okay, so once I have this function that I pass in my model, the formula, the columns, I'm going to use the column names, and the data that's was used to train the model. Then I can print out all the information. So that's the summary. It's a nice summary to have. And one of the next things you want to do in addition to that text summary is print out or graph the actual values versus the predicted values. So the way to do that is take your model that has been fitted to the training data and then transform it against some data. In this case, I'm going to transform it against the training data. I'm going to get the actual original price and the predicted price. And so once I have that, I can go ahead and plot the actual versus the predicted. And I have this pandas data frame that I converted from my original predictions. And once I have that pandas data frame, I'm going to use Seaborn. It's a ln plot. I'm going to take the summary column, which is the price column, and the prediction column, which is prediction. And I'll print out plot the actual versus the predicted. So it looks pretty good. So if you look at the statistics about the summary, R squared and adjusted R squared are above 0.9, which is good. And the plot here through the data looks like it's a pretty good plot. Okay, and one other thing that people do is print out the residuals to see that it's basically a random plot, doesn't have a particular pattern in it. As I mentioned before, when I run the summary, I get the residuals. You can compute them separately, but just it was convenience to return the residuals. So these are the differences between the predicted value and the actual value. So here's my residuals. I convert it to pandas so I can pass it off to Seaborn's ln plot. And I'm going to have my x's be my predicted column, my actual column, and my y will be my residual. And you want this to be pretty much a random scatter plot. And really, it looks pretty much random to me. In addition to that, you can go ahead and do other plots with your residuals, such as a box plot shown here, or maybe a variation on that, the violin plot shown here. Overall, this is a summary of the training data and the model produced from that training data. Typically in statistics, that's all you would do and you're done, and this model looks like it fits okay. But in machine learning, I'm going to train it first, and then I'm going to test it on a separate data set to make sure that my model is not overfitted. So I've got a training data set and a test data set. So now I'm on to the test data set. So how do I do that? Well, I take my fitted model, which was fitted against the training set, and I apply it to the test data, which was held out separately. As a result, I get my predictions with the actual values, and I can, of course, convert that to pandas so I can do some plotting with it. But before I do that, I'm going to take my label predictions, that is my prediction and my original price value, and I'll do what most people do. I'll take my regression evaluator and apply it to my test predictions, not my training predictions, my test predictions, and I'll get the number of metrics that you can get from the regression evaluator. They include root mean squared error, R squared, and mean absolute error. You notice it doesn't have adjusted R squared and perhaps some other things that you might want. So this is what you get, though, with the regression evaluator. So once I have that, I can also look at my actual versus predicted. And so as I show above here, for the test data, I converted it to pandas. And then once I have that, I can go ahead and plot the actual versus the predicted values. One of the next things I might want to do is to have a little bit more information that I had before with my summary. That is, I had this function I wrote for summary. It printed out the R-squared, adjusted R-squared, and F statistic and all of that. But I'd like to do it for the test data and not the training data. So again, I want a summary, a text summary. And so how do I go about doing that? To run the LM summary on the test data, I need to run the R formula on the test data. And that'll prepare the data so that I can then run a function called evaluate on my linear model, the model created for my training data. So the idea here is to evaluate my trained model on the new test data. All right, so in order to do that, I want to run the R formula. So I have the R formula, which was defined above. I fit it to my test data, and then I transform that, and I get some test data that now can be evaluated with my linear model. Now, I don't want to run the above pipeline again because the pipeline has both R formula and it also has the linear model. And if I ran it over the test data, it would run R formula over the test data and run the linear model over the test data, thereby creating a new model with the test data. And I don't want that. I want to run the old trained model on the test data. So in that case, I just run the R formula, which is going to prepare my data. First I have to fit it, and then I transform it, and I get this data that's prepared now to be run with my originally trained linear model. And the way I do that is I can take my linear model trained above with the training data, and I apply it using the evaluate function to the test data. And you can see the result of LM evaluate is my friend here, the linear regression summary. Well, once I have that, then I can pass that to my LM summary function defined above. It's the original linear model, trained model, the original formula, the original columns, and now the LM evaluation, the training summary, the test data summary using the trained linear model. And I also pass in the test data. Once I have that, then I get my function does all the things that I'd like it to do. It's basically the R summary of a linear model. And notice it does have the R squared in the adjusted R squared, F statistic, and all of that. One thing to note is that these coefficients will be wrong because they are not being trained with this new test data. So you have to go back to the original summary of the training coefficients. You want to get the coefficients for the model. They're defined here, and they're not going to change. That's the whole point, is that the model is the original model with the coefficients from the training data. All right, so now we're, in this case, now we're going on to take that original model and apply it to the test data. The way I do that is to take the R formula, fit it, and transform it to get my new test data, which I can pass into the original linear model. I can evaluate it. Now I've got my summary, and I print out my summary. And recall when I run my summary, it defines the residuals. And oops, maybe I need to do this, residuals. So when it runs, the LM summary returns the residuals, and these residuals will not be from the original training data, but now they will be the residuals as a result of the test data. So now I can plot those. So let's see how this looks. Okay, again, no discernible pattern. So again, based on the statistics here and the actual versus residuals, as well as the plot. I can do this plot as well. It looks like this model is working okay with the test data. So I went ahead and ran the actual versus predicted values again, just to ensure that it's the same. So for the test data, the way to get a more complete summary is to run the R formula against the test data, apply that to the original trained model, run the summary to get the text version of it, and then you can print out the charts for the actual versus predicted and the actual versus residuals. So that's a summary of how to get summary information out of a PySpark regression. I hope it works for you.